All right, doing the same thing as question 1, making the numerator look like the denominator, but this time we've got definite integrals. So the first one, the top, if I make the top equal the denominator, I have to balance it up by putting a -2. So I'm going to have the first one in the first integral. So I have x plus 1 over x plus 1 dx, and I'm going to break this bit up. So I'm going to put -2 and put that outside a second integral. So really I'm doing -2, but I'm just keeping it out the front. When I do that, I don't know why that's showing. Anyway, so when I do that, I get 1 dx, so that becomes x, remembering it's a definite integral, and I've got a -2 log of x plus 1, and it's a definite integral. So here we're going to sub 1 in, so it's just 1 minus 0, which is 1. Here I've got log 2 minus log 1, which is just log 2. So really it's just, there's your answer. All right, if I look at the next one, if I look at B, I'll just slide it across a little bit. All right, so if we look at this one, it's almost what we want, but perhaps I need a 2x. So I might just, if I can, put a half out the front. So I've got half of 2x, and I want a 2x plus 1. So just remember that we have to balance it up. We're going to force it to be a 2x plus 1, and then we're going to subtract 1 to balance it up. So my first integral, now these integrals have halves out the front, is the 2x plus 1 on 2x plus 1. Oops. So let's get rid of that. Oops, got rid of the wrong thing. Excellent. Thank you for bearing with me. So let's try again. 2x plus 1 on 2x plus 1. And the second integral, we've still got a half out the front. So just make sure you don't lose that half. So I've still got half, and it's a -1 over. And here I've got a 2x plus 1. Is that right? Yes, that's right. All right, now if you think about it, I really want, well, let's do this one first. So we've got half, and there's 0 to 2s, sorry, 0 to 2s. Okay, so this would be the integral of 1 dx, which is x. We already know that. And this one, if you think about it, you want the derivative of the bottom at the top really to make it a log. So if I want a 2 here, then I really need that to be a quarter. So I'm going to change it to a quarter, and now I've got log of 2x plus 1 between 0 and 2. So if we go back to the front here, we can put 2 in. 2 minus 0 is just 2. So we've got half lots of 2's minus a quarter. So here we've got 2 2's are 4 plus 1 is 5. So we've got log 5. And again, we've got minus log 1 here. So if we put that together, we get 1 minus a quarter. Using our log laws, just a quarter log 5. That would be our answer. All right. Okay, so moving along to the last one. So it's a negative where we want a positive. So what we can do is put a negative out the front. So let me put a negative out the front and change. That means that would now be a positive, and that would be a negative. So at the top, we've got x squared minus 3, because I've put the negative outside the integral sign. Now, if you think about it, that's what I want. I want the x squared plus 1, so I'm going to have to minus 4 to balance it up. So don't forget the negative, so let's put the negative integral 0 to 1. I'm going to do the x squared plus 1 separately from the minus 4, because the bottom is x squared plus 1, or 1 plus x squared, doesn't really matter. Now remember, you've got, so you can either change it back to a positive 4 if you want, up to you how you do it. So hang on, let me just check. Yeah, All right, so minus 4. So if you think about it, if you're keeping that minus outside the integral, there's another minus because it's got a minus 4. So just be careful to weigh that up. So really I'm going to put the 4 out the front as well, and I'm going to end up with this. Hopefully that's okay. All right, so it was negative of the negative 4, so it was a positive 4. So the first integral is just a 1 dx, of course, with a minus out the front. When I integrate that, I get an x. The next is a 4. We know this as an inverse tan x if we look at our standard integral sheet, reference table. All right, so when I put 1 minus 0, I get 1, so that's a minus 1 plus 4. And here we're going to get inverse tan of 1, which is pi on 4, and inverse tan of 0, which is 0. So we're going to get a pi on 4. So pi on 4, so the 4's cancel. So really we'll just end up with pi minus 1.